Now for the advanced stuff with related rates. So instead of working on your stuff, you might want to pay attention to this a little bit. All right. A side of a cube is decreasing at 9 millimeters per minute, and at a certain instant, the side is 19 millimeters. What's the rate of change at that instant? So what I do when I do problems like this is I actually draw the picture of the cube. Then I check and see what it's looking for. If it's looking for the surface area or the volume, huge difference. So you got to know what it's looking for. In this case, it's a volume. Well, the volume of the cube, I know each side is an edge, so the volume is E cubed. Okay? So the rate of change of the volume would be dV dt equals, and then take the first derivative of this side. 3e squared dE dt. Okay? So at a certain instant, the side is 19, so it's 3 times 19 squared, and it's decreasing at a rate of -9. Okay? So it's going to be a negative answer, whatever 3 times 19 squared times -9 is. I don't have a calculator. You guys do. If one of you could type it in really quick. And Megan just sits there going, I have a calculator in front of me, but I don't want to press buttons. -90,747. So it's A. Okay? Easy peasy, lemon squeezy. Okay? The length of a side of a square is increasing at a rate of 15 millimeters per second. At a certain instant, it's 22. So you draw a square. How do you find the area of a square? It's the side squared, right? Because side times side, so it's side squared. So dA dt is equal to what? 2s ds dt. So it's 2. The length of the side is 22, and it's increasing at 15. So it's 30 times 22, or 660. Easy peasy, lemon squeezy. The radius of a sphere. So you draw a sphere. The radius is decreasing at 4 centimeters per second. At a certain instant, it's 10 centimeters. Okay? What is the rate of change of the surface area? All right, surface area equals 4 pi r squared. So dSA dt equals 8 pi r dr dt. Okay? And then it's just simply 8 times pi times 10 times, is it -4? Yep, -4, which is like -320 pi. Okay? Two cars are driving towards an intersection from perpendicular directions. So they're each going this way. The first car's velocity is 10 meters per second. The second car's velocity is 6 meters per second. Meters per second, not miles per hour. At a certain instant, the one car is 4 meters from the intersection, and the second car is 3 meters from the intersection. So this is 4 meters away, and this one's 3 meters away. What is the rate of change of the distance between the cars in meters per second? How do we find the distance? Well, we draw it. This is 3, this is 4, so then what is this? Right triangle, people. Come on. 3, 4, 5. That's a way to know your Pythagorean triple. Okay. What's the rate of change of the distance in between the cars in meters per second? Okay. So the distance, c squared equals a squared plus b squared. So c squared is 25 equals a squared plus b squared. So when you take the first derivative of 25, you get 0 equals 2a dA dt plus 2b dB dt. Come on, Mr. Bierschbach. That's horrible. 2b dB dt. All right. So 0 equals 2. A is 10. And then we got 4. Or 4 and then 10. Yep. Plus 2 times 3 times 6. Okay. Ooh. 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 This. Hmm.
I mean, 0 could equal it.
No. It's got to be. That's not right. So c squared. So it's dc 2c dc dt. So we know c is 5. 2 times 5 times dc dt. dc dt is how much closer they're getting over time. There we go. So 2 times 10 times 4. And one of these has to be negative, obviously. Because it's a negative. If they're going towards each other, maybe they're both negative. Let's try both negative. So this is like negative 80 and negative 36. So it's negative 116 divided by 10 is negative 11.6. That's what I would say it probably is.
Some amount of confidence.
Yeah, lots of confidence there. Yeah. Well, it's, it's Khan Academy, so if you guess wrong on that, then it's a learning experience. Yeah. Hit the start over button. All right. 29-meter ladder sliding down a vertical wall. 29-meter ladder sliding down a vertical wall. The top of the ladder is decreasing at a rate of 7 meters per minute, going this way. So that's usually negative. At a certain instant, the ladder is 21 meters from the bottom of the wall. What's the rate of change of the distance between the bottom of the ladder and the wall? So we're looking for this one. So if this is A and this is B and this is C, C squared equals A squared plus B squared. So I suppose we could go 2C dC dt equals 2A dA dt plus 2B dB dt. I did it again. Because I think faster than I write. dB dt. So is a ladder changing distant length as it's going down the wall? No, so this would be 0. So 2 times 29 times 0 here equals 2 times A, where it's 21 meters away from the wall. We're looking for dA dt. Plus 2 times B. Well, what's 29 squared minus 21 squared? I think it's, no, what? 400? So that's 20. And then negative 7 here. So this is 0 equals 42 dA dt. Plus this is negative 280. So you go negative 280 on this side equals 42, or 280 equals 42 dA dt. And divide by 42. 280 divided by 42. I don't know. It's not A. It's not B.
7.
Is it 7?
I don't know, I guess.
280 over 42? I don't think so.
So we did something wrong again, so I feel like we shouldn't have to do this time. Because
It is 23rds? Okay, thank you. And no, we didn't do anything wrong. So should we do the last two, or are we good with
I
this?
think we're good.
Okay?
I understand this.
Okay, I'll do the last one. Because the second one,
I do kind of understand this.
the surface area of a cube is increasing at a rate of 15 square meters per hour. So surface area of a cube is what?
Surface area of the cube is 6
6s squared. So the dSA dt. Oh, we're looking for change in volume. Okay, this is one of those. I'm glad I did this. Okay, so what we have to do is the surface area is changing, so we have to do this first and then figure out the volume one. Okay, so dSA dt equals 12s ds dt. Okay, so at a certain instance, the surface area is 24 square meters. And so we don't know the change of it, but it's increasing at a rate of 15 meters per hour. Okay, that's a surface area. So that's 15 meters per hour. Okay, so that's 15 equals 12. At a certain instance, the surface area is 24. So if this is 24, we've got to solve for S. So 24 to what? Yes. So 24 equals 6s squared because we need to S right there. So if we divide by 6, s squared equals 4. So s equals 2. So at a certain instance, this is 2. So we're going to find ds dt. Okay? So if this is 2 times 12, which is 24, and take it into 15, 15 24ths is ds dt. Then the volume equals E cubed, right? Or S cubed. That's fine, S cubed. So dV dt equals 3s squared ds dt. So we had to find ds dt from here, plug it in over here. So 3 times 2 times 15 24ths, and then the 2 squared. So 3 times, that's 12, goes into there. 2 times 15 halves. There we are. Okay? So, related rates. There's a little bit